Question 8. So I think the hard bit here is getting your initial diagram properly drawn up with all the forces on it. So here goes. We've got the weight being straight downwards of 4G. We've got we've broken the force of 36 newtons into the two components, so this and this. We've got the friction going against the movement, so that's down the slope, and remember that friction equals mu times r, where this is r is this resistance, so remember, so r is perpendicular to the slope. So these are all the various forces in place. So remember, r, that is the normal reaction perpendicular to the slope. Now for part A, we're being asked to work out this r. So if we resolve in the same direction as r, so we resolved diagonally upwards, the forces going in that direction are obviously r, but also this component of the 36 newtons, so that's opposite, that's the sin 30, so 36 sin 30. So those are the two forces going in that direction, and the only force going opposite this is this component of the 4G. So looking at it from this 30 degrees, that's the adjacent force, so that's cos, so that's 4G cos 30, and then taking away 36 sin 30 from both sides, we get r being this, and that gives us 15.9 newtons. Now for part B, we're being asked to work out the value of the coefficient of friction mu. Remember, mu F equals mu times r. So if we now resolve down the slope, we have the forces going this direction are 4G sin 30, being this one, plus the friction, which is mu times r, and we've just worked out r to be 15.9. And the forces that is equal to are the forces going in this direction, so a component of the 36 newtons. 36 cos 30 is the adjacent force. So taking 4G sin 30 from both sides and then dividing by 15.948, we get the coefficient of friction being 0.726. Now for part C, we're now told that the force of magnitude 36 newtons is removed. So the particle carries on moving up the slope, but it is decelerating. Nevertheless, the friction is in the opposite direction, so be sure that you realize the friction is still down the slope. So these are the forces, so we've still got the coefficient of friction, which will have changed, of course, but we've got the coefficient of friction, we've got the friction, and we've got the 4G weight, the two components of that to take into account. So resolving diagonally upwards, we've got r equal 4G cos 30, adjacent cos 30, and then resolving up the slope, we've got minus 4G sin 30, being this red one here, so minus 4G sin 30, minus mu times r, both being minus because I'm resolving in that direction, so they are the forces down the slope, and they are equaling 4a. Now I didn't describe that, did I? Yes, because we've got movement here with these two the two sides, you can't just resolve the forces being equal. We've got to go back to Newton's second, where F equals ma. So the net forces are what I've just described, both these forces down the slope, but they are equal, because that's F equals mass times the acceleration. The mass is 4 kilograms still, and the acceleration is what we're going to be able to work out. We know what mu is. We know that r is 4G cos theta, so we substitute both those values in. This allows us to rearrange and work out that the deceleration is minus 11.06. So knowing that, we know the initial speed is 16. We know the it will come to rest at v equals 0. And so substituting into c that v squared equals u squared plus 2as, we get s being 11.6 meters.